Alright, here we go again. 9.37. This is an arm holding up a mass. I'm going to butcher this drawing, but I'm trying to show it. So the mass is in the hand here. The arm has a weight here. They tell you the mass is 2 kilograms. There's a force of the bicep muscle, which pulls in this direction. It's labeled F max in the picture. This is 105 degrees. This is F max. And the elbow joint is right here. And the mass of the ball is 30 kilograms. And they want to know what is the maximum force that the biceps muscle exerts on the forearm. So we want to know what this is. Somebody asked me how to do this today, and they looked at it like, well, here's an FG, here's an FG, and there's that F, and they just tried to do the sum of the forces in the Y direction, or F net in the Y, and set it equal to 0, and they just said this plus this minus this component would be 0, and they're missing one important thing. I'll do this in green. At the joint right here, there's a reaction force in that direction, and there's a reaction force, I'm assuming it's up, but I don't know, in that direction. That means when you go to sum this, you don't have RY or F max in the Y direction, so you can't do that. But hopefully some of you, if not all of you, realized that when I started to write these reaction forces here, and the fact that we didn't know them, that might be a good spot to sum the torques about that point J. So if we do the torques about J, the sum of those, they should equal 0. And what you'll see is they give you all the dimensions here. This distance is 35 centimeters. This distance here is 15 centimeters. And this distance right here is 5 centimeters. So I'm going to go back to black. I like writing that better. So if we do 30 times 9.8, sorry, I'm having to yell over my son doing his homework. You're going to get that type of torque. So we'll call that positive. Plus, oh shoot, lost my concentration. We got to multiply by a distance, which is 35 centimeters. So 0.35 plus 2 kilograms times 9.8 times 15 centimeters. Now if you notice, there's no sines or cosines here because the line of action of the forces is perpendicular to the lever arms. So that's why I don't need any signs. I'm going to subtract from that the torque due to F of the bicep. I'm only going to use the Y component because, again, if I go back to a different color here, we'll do blue. This F max, if I break it into parts, the Y component is going to give a torque that's going to be in this direction. But the X component here goes through the joint, so it doesn't contribute. So I forgot to label this one going that way. So this is in the opposite direction, this one up here, so that's why it's negative. And that's going to be F max. We want the Y component. I'm looking at it like this. This is 15 degrees. The entire thing is 105. But that little part there, that little angle, is 15 degrees. So if I want the vertical component here, I can just do F max times the cosine of 15 degrees. And my lever arm for this is 5 centimeters. No, yes, 5 centimeters, which 0.05, which reminds me that I should put this, I don't know if I did pick that or not. This one in meters is 0.15. You guys can see what I'm doing. That has to equal 0. You do all the math on this, and let's see, 30 times 9.8 times 0.35 plus 2 times 9.8 times 0.15. That equals this whole term here. So I gotta divide by the cos of 15 degrees, and I gotta divide by 0.05, and you get a pretty substantial number, which is 2191, which is why, you know, linemen in the NFL are tearing their bicep muscles. They're exerting huge forces with big lever arms to try and block, you know, 300-pound linemen. So let me just quick check the answer here and see if I'm right. I'm going to say 2200 to do the proper sig figs. Submit. Guess what? It's green. So green is correct.